Welcome to 3Dflow Academy. In this second episode, we will tackle how to take good pictures for photogrammetry. In order to take good photos for a photogrammetry reconstruction, we must keep in mind three simple rules. Rule number 1. Overlap. We must take at least 3 pictures for each point we want to be reconstructed, with a different camera position and possibly a different camera rotation. Having a good overlap between our pictures ensures that this rule is not broken. Rule number 2. Sharpness. We need sharp images. Images that are totally or partially out of focus and or blurred will only worsen our reconstruction. It's better to have less, sharper images rather than a lot of bad images. Rule number 3. Consistency. Our subject must be feature-rich and stationary. Having a subject in motion is a big problem, as a photo will not be consistent with another one. Unless you plan to do post-processing, never touch your subject. If the subject is a living creature, then you'll have to consider using an array of synchronized devices. The sparse point cloud generation is often referred as extraction from motion. The geometry, the structure, is computed along the motion of the camera, so try to take pictures of the same point from different views. Rotation only is highly discouraged, as lack of parallax will directly impact the quality of the results. So how should you plan your acquisition? Let's see some real-life examples. Parallel axis capture, often used when acquiring walls or in aerial photography. By keeping a parallel axis motion, you will be easily able to understand the overlap between your shots. Ideally, you'll have around 80% of overlap in between each picture, although very textured subjects can work easily with much less overlap. Just remember to draw a path when changing distance from your subject, so it's much easier for Zephyr to stitch your path together. Here is an example in which the parallel axis capture method has been employed, also by accounting for different heights. Here is another example. This time, however, the capture has been made with a drone, but the same concept applies. Having more flights at different heights is also a good idea in order to have a better stitch and overlap, although the accuracy and texturing will be driven by the closest distance images. In a drone-like scenario, if you only employ this method, however, you may not be able to describe certain surfaces such as walls. If those are of your interest, you should consider adding another flight with oblique cameras. Additional images from other point of views are suggested, especially if you have a complex geometry to scan. If you're dealing with interiors such as rooms, the same concept applies. Make sure to always move in between shots, as staying in one place and rotating will not yield enough parallax. Another very common acquisition method is the convergent axis capture. This is the most common method when dealing with small objects and the one we used in the first video tutorial. You should always have your object at the center of your camera frame and move around the subject, while keeping in mind that you need at least 3 images for each point you want to be reconstructed. You can clearly see how 3 simple orbits around the subject are more than enough to describe the full geometry. Think of it as creating a dome from which you take pictures of your subject. You can combine these acquisition techniques. Don't be afraid to move a lot, just remember to take photos that overlap in a way that can connect your motions. Let's quickly go through a few tips and tricks. These are just topics that we will cover more in future tutorials, but you can already learn more about them in our documentation. Masking. You can mask out unwanted parts from the images using the bundled 3DF Masquerade software. By doing so, you can cheat Zephyr into thinking that the subject is floating in space. When shooting glossy surfaces, you may consider using polarizing filters in a controlled lighting setup in order to minimize the amount of highlights. Transparent surfaces. Although some types of completely transparent objects, like this bottle, can be reconstructed with the shape from silhouette function available in 3ds Zephyr Pro, a simple trick is to alter the subject. This is obviously not always possible, but sometimes it's much easier to apply some powder or dirt to your surface to help your acquisition. In this case, about 20 years of dust are making our job much easier in capturing the car windshield. Sometimes you are not allowed to dirty the subject or you don't want to disrupt the original texture. There are some cases, especially with completely uniform surfaces or repeated patterns, where simply projecting a random pattern onto the subject can allow you to safely reconstruct the surface. You will need some controlled setup in order to take 2 images, one with the pattern on and one without, for every shot, or you'll have to forget about the original texture. Once you need to extract the texture, you can simply tell Zephyr to change the images in the workspace with the same shot with the projector off, like I did to reconstruct this small engraving on my workstation. This is mostly used in reverse engineering. Other methods include the usage of markers placed in the scene, but we'll go through these techniques in future tutorials. This part tackles camera setup a little more in detail. If you're already familiar with your camera, you can skip directly to the end of this video. Grab your camera and follow along. If you have a DSLR or a mirrorless device, you're pretty much guaranteed that you can tweak any of the following parameters, while if you have a compact camera or any other consumer-grade device, then you may not have a fully manual mode. That's okay, but you'll have to adapt a little bit. When taking a picture, we can adjust three primary parameters on our camera: shutter speed, aperture, and ISO speed. All these parameters contribute to the exposure of the camera sensor to the light, which in turn becomes our photography. When the light comes into contact with the camera sensor, the image is composed according to those parameters. Shutter speed. The length of time when the sensor inside the camera is exposed to light is referred to shutter speed or exposure time. The sound you hear when taking a photo is the physical shutter that opens and then closes. Halving the shutter speed means halving the amount of light that is allowed to enter the camera. A shorter exposure time will yield a darker image, but will suffer less from motion. Aperture. The aperture is the opening through which light travels. The aperture value is identified with the f/ symbol on all cameras. This parameter will directly impact the depth of field of the image. Higher aperture values means that the opening is very small, so don't get confused by this, leading to smaller amount of light to be allowed. Lower aperture values will lead to higher amount of light. So why should we choose a larger aperture value rather than a lower value? The answer is depth of field. If we want everything to be in focus, then we have to use a high aperture value. Look at this example. All the parameters of these photos are the same, except for the aperture. The images are very similar, but only the foreground object is in focus. We have to be very aware of this when taking images, as out of focus portions will not be reconstructed by photogrammetry, or worse, they will bring noise. ISO speed. This value measures the sensitivity of the image sensor to the light. The same principles apply as in film photography. The lower the number, the less sensitive your camera is to the light and the finer the grain. It is always a good idea to shoot images at the lower ISO speed available, usually ISO 100. Take your time and experiment a lot. You'll notice that sometimes, in order to take usable photos with some parameters, you'll need a tripod and sometimes even a remote. That's okay, as in some cases, that's your only option to get a sharp image. Another important parameter we can control is white balance, especially when texturing is critical. White balancing is the global adjustment of the intensities of the colors. You will probably find very similar icons on your camera that allows you to select the correct value for the environment in which you're shooting your images. If you're shooting in RAW format, remember that the software suite of your camera allows you to directly change the color balance after you've taken the image. This is something you may be tempted to do in a Photoshop or other software to your JPEGs files, but be wary that due to compression algorithms, the synthetic white balance you apply to JPEGs will not be as good as the one you can do with the RAW format files. Take your camera and have a look at it. As you can see, you can tweak all these parameters on your camera. Just make sure you set it to manual. Even a high-end camera can give bad results if you let it take pictures automatically or if you set some of the parameters too high or too low. Let's talk about the camera sensor. This electronic device detects and conveys the information that constitutes an image by converting the variable attenuation of light waves, as they pass through or reflect off objects, into small bursts of electric current that convey the information into digital form. In layman's terms, the bigger the sensor, usually the better the image quality. As you may already know, there are all kinds of lenses, from fisheye to wide angle and telephoto. Some of them will bring more distortion than others. You may be tempted to fix that distortion into pre-processing software, such as Photoshop. Never do that. Photogrammetry software actually uses the full image to understand depth. Removing the distortion will remove information from the image. You have to let Zephyr distort your image for you. This is done completely automatically. If you're still very worried about your lens distortion, for example when dealing with fisheye lenses, what you can do is manually create your own camera calibration. To manually create a camera calibration, run the camera calibration tool in 3ds Zephyr. Simply open it up, let it show the calibration pattern and take a few pictures, at least 10. Make sure to keep the same focal length for all the photos you take, as you need a new calibration for each different focal length you use and feed them to Zephyr. The camera calibration can then be saved and used in different projects. We will go through a more in-depth tutorial about camera calibration in future tutorials. Let's see some common mistakes and how to fix them easily. As you can see in this photo, the subject is partially in focus. Since we cannot change the lighting in this scene, in order to improve this image, the easiest way is to increase the exposure time while using a smaller aperture. Please note that when you are using a tripod, pressing the shoot button may shake your camera. A remote is suggested if it is available. On a first glance, this photo doesn't look too bad. However, if we zoom to its real size, we can see a lot of noise due to a very high ISO speed. We can simply lower the ISO speed a bit, use longer exposure time, and the result is much better. If you can't retake your pictures and you are in a similar situation, consider using a lower resolution in the advanced parameters in 3Dflow. This photo is not too bad, but the photographer's shadow is disrupting the consistency of the scene. Always be aware of shadows and moving objects in your scene, as it takes just a few more seconds to plan a correct shot. These photos are good, but you won't be able to reconstruct the full subject. There are just not enough photos to describe the subject in its entirety. The only way to salvage this dataset is to go back and take more photos. Thank you for watching, and don't forget to join our 3Dflow Academy Facebook group. We are also running a contest which will end on November the 20th, 2017. Enter your reconstruction to win a full 3ds Zephyr Pro license.